Okay, it's fine. So the recording is ongoing now. So we'll first of all look at what are the parameters. Please, I just want you to follow me. There are so many things that people don't know about this motor driver, and I think I have a very strong understanding towards it. And there's a project I'm doing currently which I'm going to also use it to cement our knowledge on this motor driver. Like, if you see it working in a physical product, you should be able to also be able to relate with it. So these are the pin out he has. So let's first of all address the ones I've explained. In 1, in 2, responsible for out 1 and out 2. Now, let me turn back to H-bridge circuit. You see that in 1 is these 2 switches connected together. In 2 is these 2 switches connected together. Did we get it? So imagine that we join that 2 switches together, and that's the in 1. And imagine we join the 2 switches together, that's in 2. I want to show something. So I actually have 16 conditions that we could be. God, I want to break this thing down so small. So how do we actually construct robotics car? How do we do it? Now, this is the mystery. Let me show something. Smart car. Smart robotic car. So, image. So, and this thing I'm saying, it doesn't have to be this small car. I've used the same principle for, even big lawnmowers, big robots. It's the same thing. You see these 2 tires now that I'm pointing at, that are in the same direction like this. You will connect them in parallel. But before you connect it, you ensure that they are all going in the same direction. You understand? That this one is not going this way. Can you see my cursor? That this one is not going this way, while this one is going this way. You have to ensure that they are both going in the same direction. These are the 2 motors here. This one and this one, in this case now. You ensure that they are going in the same direction. So when you join them, how do you do that? You can take a small battery, test this one, take another small battery, test this one. So red goes to red, black goes to black. Do you understand? Then you now feed that one side to one H-bridge. Are you with me? Then you connect the other 2 ends like that. You feed it to the other H-bridge. And that's the reason why they put 2 H-bridge inside the motor driver. Because they know that you need 2 H-bridge to achieve this. So there's no motor driver you will find that has one single H-bridge. It's 2 H-bridge. Now let me also say this. The major IC here is this guy. This is the L2987. This particular IC here. Now, out 1, out 2 for left side tires. Out 3 and out 4 for right side tires. Do you get now? Being controlled by in 1 and in 2 for left side, in 3 and in 4 for right side. Is that clear now? That's clear now. If that is good to go. Now it means that if you have 16 scenario, if you have 4 input, logic told us what? Logic told us that you can have 16 scenario as a result of that. Accepted. Share 1000. You understand? You know how we did this thing in logic now. You first of all do 111 in 8 places, 000 in 8 places. Then you go to the next one. You do 11 in 4 places, 00 in 4 places, 11 in 4 places, 00. Please, is anybody getting what I'm trying to explain? And that will lead us to, or is something we can just simply say that it's 2 raised to power 4, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. That you have 16 different conditions as a result of this. Please, is it clear? Hello?
Yes, sir.
So, now, let's look at scenario 1, when you have 0, 0, 0, 0, 0. That's in 1, 0, in 2, 0, in 3, 0, in 4, 0. So, what you have in that condition is that the motor is not going to move. Yes or no? Yes. The motor is not going to move because all these switches are open. Power is not getting to the motor from anywhere. So if you have 1000 notes, how will I do this? I think I will. Okay. If you have 10000, you know this is 1. S4 and S3. S4, S1 and S4, they are 1. What will happen here? Ah. The principle behind turning or maneuvering is that the side at which you want to turn to, you keep that side constant. While the other side, you move it. And once you do that, you find yourself at the other side. So you want this car to turn left. What you do is that you hold left tire. You hold it, you don't allow it to move. While you move the right tire, what will happen to this robot is that it will turn right. It will turn to the direction at which you keep. That's the truth. You can go and try it. If we take an aircraft as an example, for instance, if you take an aircraft as an example, the side at which aircraft want to go, it tends to reduces the lift at that side, then increases the lift at the other side. You know that when you talk about aircraft, he has control surfaces, and he has 6 control surfaces: the ailerons, the rudder, and the elevators. She understand now. So if you want the aircraft to, aircraft also has 3 axes at which it moves. She understand? 3 axes. I'm using a lot of different things to explain the same thing because we are not in physical class of aircraft. If it is in physical class, I would have been able to demonstrate this with even my movement. There's something we call yaw, there's something we call row, and there's something we call pitch. I think we need that safe. Yaw, roll, and pitch. So let's just take this. This kind of movement is called, I believe, yawing. Can you see that the aircraft tends to do like this? Look at the position of the ailerons. You increase the lift force here. You see it was bent downward. To increase the lift force here, the side you want to bend, what did you do? You reduce the lift force there. Did we get it now? Now, when you want to do, is this one rolling? But whatsoever this movement is called, you see the rudder. You use the rudder to increase the force here and reduce the force here. What happens to the aircraft? They just shifted that way. So it's the same principle we are using in smart or any robotic car. If you hold this leg and you don't move this leg and you move this other leg, this place will tend to turn the car in that direction. So I explained the second scenario like that. Then the third scenario to the other side, the fourth scenario, the fifth scenario. Every of the scenario you now have an implication. Please, is that clear? Is that clear?
Yes, sir.
Now
Yes,
let me
sir.
give us another very critical instance. Oh, shit. I believe I should be able to show this in one way. Let me just do something on Pro Tools. It doesn't have to be. So let me use triangle. Let me use this to represent my car. So I could have the movement forward, backward. That one is clear now. Look at this. I can have. Let me do this also. My aim of doing this now is to try to say that this is the forward and this is the front side of the car. She understand? So that we will not get, will not miss what I'm trying to explain. Perfect. So let's say this is the front of the car. Now, so there is a way you will move left this way. Can you did you accept with me? You can move left this way, left this way. You can move right this way, right this way. Can you see? Are we together, please? But it's also possible to move. It's also possible to move left this way from the backward end. Did you see? And left this way from this backward end.
Yes, sir.
That is also another scenario, but that scenario will now be the opposite of the scenario of the front. I've explained front, back, for 2 scenario here, 2 scenario, 8 scenarios has gone like that. Now, what are the other scenarios? Now, scenario at which you have 1, 1, 1, 1, 1 in there, and these things were simple to write. This thing was simple to write. Let me show you. They were pretty simple to write. Very, very pretty simple to write. All you have to do is to write 10, the way we have been writing 1001 on LED. Abi, it's the same thing. You write 1001, and this motor driver will get the work done for you. It's the same theory. Nothing has changed. So these 2 inputs control these 2 outputs. These 2 inputs control these 2 outputs. The next question is, do they actually have polarity here? The answer is that there is no polarity. No positive, no negative. If you can imagine that as you are changing this 1 and 2, the polarity here is also changing. That is the truth. So let me move to the pin called ENA and ENB. So what is ENA? ENA is actually enable for motor A and enable for motor B. So what is enable for motor A? Enable for motor A is like you are trying to send how much current, which current now work with the speed, how much current or how much voltage did I want to use to drive this my motor. So reducing this enable, now this enable is 5-volt logic. I have to explain this. It's 5-volt logic. So if you put 5 volts there, it means that the motor should run at the maximum power that you connected to this place. So if you put something 3.3 or 2.5 there, it means that you should run at the half power of this. That is what it means. So as you keep, so the enable is what helps us to control the speed. Now look at this board. There's a bit little jumper here, jumping enable A to something behind here. Oh, can I do this physically? I have it here. Don't worry. I'll connect my phone now. 1 minute. Let me just connect my phone and pin my this so that it can be showing in the recording also. Sorry, 1 minute. So I can stop sharing. Let me just stop sharing. Then so let me just go to where I have light on. I should bring light here. Is your pin is for everything. Alright. I'm not too sure what I'm saying. So this one that I just removed now, they were my in 3 and in 4. And you see, for this purpose now, I just need only one motor. So I'm not using the other side. That's why you see only 2 inputs coming to this place. Now this is the jumper I'm talking about. Let me just use something to point towards it. Okay. This is the jumper I'm talking about. Let me use something to point. So this is the jumper. Yeah. This jumper. It tends to connect one enable to 5 volts because there's a 5 volts here. Connect this one enable to 5 volts here. So that's, you see, I've removed this one, but the other enable I have not removed it. So if I want to remove this now, so let me show you. This is the jumper now in my hand. That's the jumper there. So if I'm plugging it back here, you will see it's here now. So this is 298, and that's how it works. So let me just move on. So it has an onboard 5-volt voltage regulator. This is the IC here. This is 7805, generating a 5-volt output into this pin. So these are the 2 places where you connect your positive of your battery and negative of your battery. And this is IN1, IN2, IN3, and IN4. Enable A first and enable B second. This is what is on motor driver for this. So if I'm using my microcontroller to control this now, writing 0000 to this pin, now I can just declare port C, for example, as my motor control. She understand? Writing 0000 will make no motor move. Writing 1010 will make them to move forward. Writing 0101 will make them to move back based on your connection. Writing 1000 will make this motor to move like this. Okay, I think now that I have my stuff here, my camera here, this is what I was trying to explain. So take this book as my car now. So take this book as my car. So this is what I'm saying. See, if I want to go in this direction, I want to move my car in this direction, all I have to do is to stop motion here. See, look at what will happen. You really stop motion here to cause this to happen. And that's that scenario. This is another scenario here. This way. This is one scenario here. This is another scenario here. Backward. This is one scenario like this. This is another scenario like this. That's it. Now there are also more combinations of scenario that will give you something like a circle like this. That will give you something like a circle like this. It's a combination of some kind of enable and this, and some of these things that does that kind of movement. So basically, what you find on 298 motor driver is what I just finished explaining that way. Please, I would like us to ask questions. Please ask questions so I can.
Yes, for me, I don't really have any question because I understand this system. That's I think I dropped the comments.
All right. Okay.
Yeah,
Let me just check.
I would say that it's a differential drive system.
Yeah. Okay. So that's good. So you can have let me stop this. You can have motor driver. Sorry, 1 minute. You can have motor driver even at another level. So let me show for you are working on a bigger voltage. You are working on a bigger voltage. It's not like this kind of motor driver will not work for 24 volts. They will actually work for 24. It works between, I think, 4 volts to 36 volts, but might not be able to support the higher current that you are looking for. So let me just do my job like by showing you. I'm going to share a link of a motor driver with you that should be able to do and that advanced one. So the same control is being used. I'm going to share a link of 2 motor driver from AliExpress that will do that. Let me quickly do that now so that we can look into that. I don't want to be searching AliExpress. Let me just check my cart and copy the what's it called? Copy the link and we just look at it together. 1 minute. Okay, so we have BTX 7679 system. It will do the job. I think I have to now in my office. BTS 79 system. Motor driver is already there. So it's on Amazon and you can see it can support up to 43 amps. It's also dual HB bridge. Everything we explained before stand for this. Its own logic also is what 5 volts, but it has a bit different between because you have PWM. PWM simply means speed control. Also, don't know if they have this. So it can work between 6 volts to 24 volts, and it can support 43 amps. Its logic level is 3 to 5.0. Use PWM to control the speed. You understand? When RN is forward, high level, low level off, and things like that. It's the same thing we have been doing, except if you just keep little watch around this thing, little things around the data sheet, you get what they are trying to say. It's very, very simple. If I could look into this, except maybe tomorrow's class, I will just bring it. So look at the pinout. That's the old pinout. VCC ground, R input left side, R enable left side, R input left side and right side. They just have it right side and left side. Then PWM in right side, PWM. Oh. Okay. I'm actually recording the class, Uche. I believe, okay, you say you can't hear me. Let me just, sorry. Okay, Uche says she can't hear. So I just want to. So I'm actually recording the class for you so that you could go over it again and just make it useful for you. So what we have here is that if we now look at all these 8 pin now, this is a very big motor driver. It's not a small motor driver at all. If you look at this 8 pin now, so if I go down and it's clearly said here, PWM talks about forward level PWM signal is actively high. So this now works between, this value is actually an analog value that works between 0 and 255. I believe that's 8 bits, and 255 means maximum power. You understand? That's the duty cycle. While 0 means 0 power. You understand? Likewise, the same thing applied to, I just say it's 2 ways. That's inside. So enable, enable, make a forward drive enable input is high level enable, and low level off. That means 1 we turn it on, 0 we turn it off. This will do reverse directions, like the 1 and the 0 and the, like in A, in 1, in 2, in 3, and in 4. That's just what they are trying to explain. And it's a very, very powerful motor driver. Now it's powerful. And I can still also give some other recommendations for motor driver. Let me try one more that I know that will work. So there's this one I've been using also, but this is so certain that it's going to work. Well, AliExpress not bringing down. I might also share the link to all these particular products so that you can buy them from AliExpress on our this thing. Sorry, 1 minute. Good. So I just share the link for this from AliExpress. You can just pick it up. Okay. That being said, so we have that. So that's basically motor driver for variable frequency drive. This is used for AC. So if you want to drive AC, you want to control its speed, you want to control. So this is what you will use with your microcontroller, then you're able to achieve your motion control. I'm already running on low battery presently as we are running now. So I believe tomorrow we'll make progress from here and we'll be able to make it better like this. So since there were no questions from you on Kokiki and Uche cannot hear us, we'll definitely end this class now. Then we make progress tomorrow. Maybe I will just disconnect this motor driver and just add 1 or 2 motors there. Then we'll write a code on microcontroller that does motion control. Then by tomorrow also we'll be able to see physically how all these voltages runs and turns out to be.
Okay.
With this, we have come to the end of today's class. At least, basically, I'll look at this in then I'll take it off and writing codes tomorrow and see how we can actually do the control. What was that problem? I might even come with a smart car tomorrow just to
Nice.
demonstrate it, to demonstrate
Oh,
all the whole scenarios that is possible in this. All right. That being said, good night, everybody, and we'll see you
good night,
tomorrow.